It had been months since astronauts Neil Arora and Riko Tanaka returned from the International Space Station, but their thoughts still drifted to the stars. Today, they sat in a quiet conference room preparing for a new kind of mission, an outreach club for students about solar flares and coronal mass ejections. With excitement bubbling in the air, Riko began outlining the wonders of the solar system, captivating the eager young minds as they leaned closer to grasp every detail. As Neil guided them through the intricate dance of the planets and their relationship with solar flares, the students' curiosity ignited and their imaginations soared towards the cosmos. The room was alive with energy as Riko unveiled captivating footage of solar flares, sparking discussions among the students about the mysteries and marvels of our universe. With hands-on activities, Neil and Riko encouraged creativity and teamwork, allowing the students to express their newfound knowledge through innovative projects that brought science to life. "Let's not just tell them," Riko said, pointing to a solar flare image. "Let's show them what it felt like when that CME hit us in orbit." The three astronauts had teamed up with a local school to run a special after-school club activity focused on solar flares and coronal mass ejections, CMEs. Their goal, to show students how the sun, something they saw every day, could affect life both on Earth and in space. Riko and her fellow astronauts worked tirelessly creating interactive experiments that allowed the students to feel the power of solar phenomena. They explained how a coronal mass ejection could disrupt not only satellites, but also power grids on Earth, leading to widespread blackouts. The excitement in the classroom grew as students began to understand the real-world implications of the sun's energy. As Riko demonstrated the experiment, students gasped in amazement when the light bulb flickered to life. This simple yet effective demonstration captivated their imaginations, allowing them to visualize the connection between solar flares and real-life applications. Riko smiled, feeling fulfilled, knowing that she was inspiring the next generation of scientists and explorers. By the time the bell rang, the classroom was buzzing with excitement. Students gathered around, eyes wide, as Riko began. "Imagine being 400 kilometers above Earth," she said. "You're floating in space, and suddenly the alarms go off. A solar flare has just erupted from the sun's surface." A hush fell over the room. The students were captivated, their imaginations ignited by the thrilling scenario. Riko continued, "What would you do? Would you panic or find a way to stay calm?" The room buzzed again as they began to envision themselves in such a moment. As students raised their hands, voices filled the air, each one wanting to contribute their brave ideas. Riko smiled, thrilled to see her classmates so engaged in a journey beyond their wildest dreams. Riko, encouraged by their enthusiasm, said, "Let me tell you about solar flares and how they can affect satellites and astronauts in space." The classroom fell silent again, ready to absorb this new knowledge. One student raised their hand and asked, "What happens next?" Neil smiled and replied, "That's what we're here to explore." He explained how solar flares work, how coronal mass ejections can knock out satellites, and the ways in which astronauts aboard the International Space Station stay protected. Curious, another student asked, "What is a solar flare?" Neil took a deep breath and began to explain. "A solar flare is a sudden and intense burst of radiation coming from the release of magnetic energy associated with sunspots. These events can cause disturbances in space weather which may affect communications on Earth." He continued, "When these solar flares are followed by coronal mass ejections, they can send massive amounts of solar material toward our planet, potentially knocking out satellites and power grids." Neil noticed the students' curiosity growing as he clarified, "That's why it's crucial for satellites and space missions to monitor solar activity. We have systems in place aboard the ISS that help us predict when these events might occur." He emphasized, "By understanding solar flares and CMEs, we can take appropriate precautions to ensure the safety of astronauts and technology on Earth." Riko explained, "A solar flare is a sudden burst of energy from the surface of the sun. It also emits a very powerful radiation that affects the Earth like GPS becomes inaccurate, radios stop working properly, and much more. Then a solar flare is not very dangerous. One student scoffs. As Rico continues, she addresses the concerns of her classmates, shedding light on the science behind solar flares and their actual impact on technology. The atmosphere in the room shifts from skepticism to intrigue as students begin to understand. Curiosity sparked. One student eagerly asks about how solar flares interact with satellites and what that means for daily life. Rico, encouraged by the interest, explains further, highlighting the importance of understanding these cosmic phenomena. The discussion grows lively as students gather in groups contemplating the real-world implications of solar flares, while Rico keeps guiding them through the intricate connections between space weather and modern technology. Neil replied, "No, it is very dangerous as it releases radiation like X-rays and gamma rays, and long-term exposure to radiation can cause cancer, and it may cause coronal mass ejection, or CME." The students asked, "Then what is CME?" Neil took a deep breath and explained, "CME is when the sun releases a large amount of plasma and magnetic fields into space, which can impact satellite communications and even cause power outages on Earth." The students listened with wide eyes, eager to learn more. He continued, "These ejections can disrupt technology we rely on every day, like GPS and even cell phone signals." A sense of realization dawned on the students as they began to understand the implications of solar phenomena. Neil smiled and encouraged the students to ask questions, saying, "What other ways do you think this might impact our daily lives?" The room buzzed with energy as they began to share their ideas and theories. "Then, what is CME?" the students asked. Rico explained, "A CME, or coronal mass ejection, is a large-scale expulsion of plasma and magnetic field from the sun's corona, its outer atmosphere. These eruptions can shoot billions of tons of solar material into space at speeds ranging from 250 kilometers to over 3,000 kilometers." One student raised their hand. "So, is CME very dangerous?" Rico replied, "While CMEs can pose risks to satellites and power grids on Earth, they also create stunning auroras when they interact with our planet's magnetic field." As Rico continued, she emphasized that these solar flares can disrupt communications, but they also remind us of the powerful forces at play in our universe. The students' curiosity deepened as they learned about past CMEs that caused disruptions, sparking discussions about science and the impact of solar activity on daily life. Encouraged by Rico's enthusiasm, the students began to brainstorm ideas on how to protect technology from the potential hazards of CMEs, fostering a collaborative atmosphere. The students remained curious, each raising their hands enthusiastically, ready to ask more questions about the wonders and dangers of space. As the astronauts responded thoughtfully, they illuminated the students' minds with explanations revealing the intricate beauty and challenges of the cosmos. With every question asked, the room buzzed with energy. Hands shot up as students probed deeper into the mysteries of the universe. Rico, radiating enthusiasm, articulated each answer with clarity, sparking a sense of wonder that enveloped the entire classroom. As questions flowed, Neil addressed the complexities of black holes, describing their immense gravity and unpredictable nature. The students, captivated by his words, scribbled notes feverishly, their minds racing with thoughts of exploration and adventure. Intrigued by the idea of life beyond Earth, a student asked about the chances of finding alien civilizations. Rico smiled warmly and began to explain the vastness of the universe, illustrating how many stars potentially hold habitable planets, filling the students with awe and curiosity. The classroom erupted into small groups, each buzzing with theories and ideas about aliens and what life might be like on distant worlds. Rico and Neil shared a knowing smile, realizing that their mission was not just to educate, but to inspire the next generation of explorers. One bold student stood up passionately, describing a unique theory about how aliens could communicate through colors and light. The room buzzed with creativity as Neil and Rico encouraged this imaginative thinking, reinforcing the idea that exploration begins with curiosity. Rico commended the student for their imaginative approach, emphasizing the importance of thinking outside traditional boundaries. As Neil listed the intriguing homework questions, the students buzzed with excitement, eager to dive deeper into the mysteries they had just begun to uncover. As the lesson wrapped up, the room was filled with a palpable sense of determination. Students were not just completing assignments, but embarking on a journey of exploration. Rico and Neil, witnessing this transformation, felt a deep sense of fulfillment, knowing they had ignited a spark of curiosity that would last a lifetime.